Hello everybody. Today we're going to focus on deploying, exposing, scaling, and updating an app in Kubernetes, along with a couple other things along the way. So as we start all these live streams, I'd like to say welcome. I'm here in St. Louis, Missouri. It's getting pretty cold here, but please say hello on the live chat and where you're from. And if you're watching this after the live stream is over, unfortunately you won't be able to participate in the live chat, but I still love hearing from you, so feel free to leave a comment below. I'm going to switch over to my screen share here. And one thing that I noticed was some people, especially in episode 1 when we were starting to use Minikube, they were having some trouble installing it, or some people had corporate policies that prevented them from installing it, or a couple people actually now have M1 Macs that you can't currently run Minikube on. There are ways to work around those kind of things, but in general, some people have had trouble getting Minikube working on their computers. So I actually recorded a separate little video clip for you to show you a way that you can have a free cluster for testing in the cloud so that you don't have to worry about anything running on your local computer. As long as you can get Kubernetes running on your local computer, you can work with that cloud. And all the examples today, and I'll try to make this the case for the rest of this course too, all the examples today will work just as well in this cloud cluster as they would in a local Minikube instance. So here is that video. Back in October, I had a crazy idea. How fast can I get 50,000 Kubernetes jobs deployed in a cluster? After this live stream is over, I'll link to the video I made exploring Kubernetes jobs in a card above me, but if you're watching live, check the description for a link. Linode generously sponsored that milestone video, and they also gave me a link that I could share with anyone to get a free $100 credit on Linode to develop and test in one of their Kubernetes clusters. And I'm happy to report, even though they aren't sponsoring this video, that's amazy.io, that link that they gave me still works. And so if you're having trouble getting Minikube running on your computer, or if you just want a cluster with no fuss to test things out, please visit the link and sign up for a Linode account. The link is in the description below too. Anyways, assuming you've created a Linode account, creating a cluster is really easy. After you log in, go to the Kubernetes section of the Linode control panel. Label your cluster. In my case, I called it Kube 101 after the series. Choose a region, ideally one that's close to where you are so that things don't get too slow. Then choose a Kubernetes version. I chose the latest version of Kubernetes that Linode had available in December 2020, that's today. But if you're watching this a few years from now, it'll probably be really outdated, so just choose the latest version. Then add some nodes to a node pool. You could just add one server, but I like to use at least 2 servers in any cluster that I build, just to make sure I don't get lazy and build things that work great on 1 server clusters, but break when you have 2, 3, or more. Once you click Create, it should only take about 2 minutes for the entire cluster to be up and running. To be able to connect to the cluster, you have to download the kubeconfig file, and Linode gives you a handy download link. So once all the nodes are running and the kubeconfig link is available, download it and then switch over to the command line. Minikube automatically configures our kubeconfig file for us, and we haven't really talked about it before, but a kubeconfig file describes exactly how to connect to a Kubernetes cluster's control plane, so we can use tools like Kubernetes to work with the cluster. What I like to do is copy cluster kubeconfig files, try saying that 5 times fast, into my .kube folder in my home directory. So I'm moving the kube101-kubeconfig.yaml file I downloaded earlier into the path home/.kube/config-kube101. Now I need to tell Kubernetes what cluster kubeconfig to work with, and I'll do that by setting the kubeconfig environment variable. And now I can start interacting with the Linode Kubernetes cluster just as easily as any other cluster like a Minikube cluster running locally. And with that, I'm going to hand it back to, I guess, myself. That's a little awkward, talking to myself, but that's kind of how you have to be when you're working remote alone all this time. But anyways, so now we have this managed Kubernetes cluster, but I want to go one step further. I'm going to talk about a lot of things in this series, in the Kubernetes 101 series, that relates to setting up a cluster, getting the tooling around your cluster, all those kind of things. And a lot of that is stuff that you might not even want to have to do. You might have to spend a lot of time dealing with all the surrounding parts of your cluster. And I mentioned in that video, Linode was not the sponsor, but I'm just extending that generous offer that they gave. because a lot of you might want to have a cluster to run. But Amazy.io is actually sponsoring the series, and I thank them so much because they have made this possible. And a company like Amazy.io basically takes all those parts that require a lot of maintenance and building your Kubernetes cluster and managing it and making sure all the right parts are put together inside of it so that you can manage your applications on it. They do all that stuff for you, and they make sure it's monitored well, they make sure it's running well, and they'll do that in any cloud environment, whether that's Amazon or Google or Azure. And they can work in all those different places and help you to make it so that all you're managing is your applications. So today we're going to focus on application deployment in Kubernetes, and the end goal for any of us is to make it so that we're not managing Kubernetes, we're managing our applications. And a company like Amazy.io does a great job of helping you work on your applications, and they'll take care of all the complicated Kubernetes parts. So anyway, we have this cluster running, and whether you run it in Linode or in Minikube or in some other environment, these directions, one of the great things about Kubernetes in general is that your definition of how to run an application will work anywhere, whether it's local or in the cloud or in some other environment. As we go along further in the course, there are some things that are more specific to certain cloud providers and things like that, but I'll warn you about that when we get to them. But we want to run that Hello Go app, and let me bring up a browser window here. It's on my other computer, so let me bring it up here. Over on hub.docker.com, in the last episode, I pushed up this Kube101-Go app, and it's a private repository on Docker Hub that only I can pull from and only I can push to because it's in my private account. And so we want to run that in Kubernetes. And thank you to Andy, and also I can't see who else it was because it scrolled past already, but thank you so much for those super chat donations, helping make this series continue and be sustainable. Although Linode, I should say generously, is donating the cluster time for me that I'm still using for the series. So thank you to them for that as well. So I want to run this in Kubernetes. And I have a Minikube cluster running locally here, and it's running Kubernetes 1.19. It's funny, Kubernetes 1.20 was just released in the past week, and so now already the video that I just made, it is the latest version you can get on Linode's version of Kubernetes, but I'm sure that they'll be coming out with 1.19 soon and probably 1.20. So in the world of Kubernetes, anytime that you commit something to a video, it's out of date within probably a few hours, if not a day or a week. And thank you also to Roger. Very generous. Awesome. So I want to run this app inside the cluster. So I'm going to say kubectl create deployment. And this is the same thing that we did in episode 1. Just creating a deployment. I'll call it Hello Go because that's our little app, the Kube101 Go app. And then I'm going to give it an image. Equals geerlingguy / and this is just coming from here, geerlingguy / Kube101 Go. I'll even copy it out of there, save a little time. And then I'm going to deploy version 1.0.0. That was the version that we created last week, 1.0.0. And I'm going to go ahead and deploy that, and I'll watch this deployment. Watch kubectl get deployment. And again, I mentioned this before, but I'm saying kubectl just because that is an official way. It's kind of like if you're saying the word GIF under protest. I am saying kubectl under protest, but when I say that word, you can substitute it for whatever you want to say. A lot of people say kube control because it's like system control, kube control. Anyway, off on a tangent there. So I'm going to watch this deployment, get deployment, hello, go, and see what happens here. And I noticed that there are no pods available in the deployment, and that's not a great thing. It says ready 0 out of 1, and this is a tiny container image, so it should download pretty quickly. So I can say kubectl get pod, and I'm going to use a label of app equals hello go. Now this is a special label. Kubernetes allows you to label things, to be able to identify them, to be able to use them in other places. And by default, when you create a deployment like this, it will create a label. The app is equal to whatever the deployment name is. So that's a handy way to get any pods that are part of this deployment or get any other resources part of this deployment. So I'm just going to say get pod with the label app equals hello go. And it's saying that there's an image pull backoff status. Typically, if a pod is working, it should just say status running, or if it's a job pod, it should say like status completed or finished or something. So this is something bad, and I want to dig into what is causing this. So I'm gonna actually use, instead of kubectl get, I'm going to use kubectl describe. Describe gives you a little bit more detail on the command line about what's going on. So kubectl describe pod-l app equals hello go, not ag. And I can see here that it's saying failed to pull the image. For most things in Kubernetes, the list of events will give you some good debugging information to get you started. And here it's saying that it failed to pull, and the daemon that's running that is trying to pull the image says that pull access was denied. It may require Docker login. So it looks like we might need to actually authenticate to the cluster, or authenticate to Docker Hub, which makes sense. Minikube on my computer right now doesn't know how to connect to Docker Hub as me, so I'm going to need to tell it about that. And I made another little video, so I will hand it off again to myself and let you guys see how I'm going to connect this Minikube cluster to Docker Hub. The reason my Hello Go deployment is failing is because Kubernetes is trying to pull a container image from a private image repository on Docker Hub, but the Kubernetes cluster itself doesn't have any authentication credentials it can use to do that. So we can create a special kind of Kubernetes secret to store our Docker Hub private registry credentials, and then tell Kubernetes to use that secret when it tries running the Hello Go application. What's a Kubernetes secret, you ask? Well, there's special objects you can store inside Kubernetes containing sensitive information like passwords, tokens, or keys. There are some special types of secrets, like a Docker registry secret, which require a certain format when you're creating them. And so to connect our little cluster to the Docker Hub registry, I'll create a Docker registry secret and name it regcred. The syntax for that is on the screen right now, and you can pass in a username, password, and email. And if you're connecting to a registry besides Docker Hub, you would also need to pass in a server with the option docker-server. And here's one important thing to remember. The password is not the password that you use when you log into Docker Hub in your web browser, but instead it's the value of an access token you configure in your Docker Hub account settings in the security section. And oh my gosh, I hear you saying right now, did Jeff just expose his Docker Hub access token to the whole world? Is Redshirt Jeff trying to create a little mayhem? Relax, by the time that you're watching this pre-recorded segment, I already deleted that access token. Or at least, I hope I remembered. But back to the task at hand. The regcred secret can be used wherever you need pods to pull container images from the private registry. To use it, you can edit a deployment template like the Hello Go one we just created. For example, run kubectl edit deployment hello-go, then go to the spec section under template and then spec, and add image pull secrets, which is a list, and add one list item with the name regcred. At this point, if you describe the pod that's part of the Hello Go deployment with the same kubectl describe pod command from earlier, you should see it's pulling the image. There are a few things you need to keep in mind with pull secrets. Every container registry provider uses slightly different terminology and may use different types of access control, so refer to the official documentation for how to connect to your registry if you're not using Docker Hub. And some container platforms even do all the authentication for you, assuming you use a container registry that's connected to the Kubernetes platform, like with Amazon EKS. And one last note, we aren't going to dive into the concept of namespaces yet because everything we've done so far is in the default namespace, but pull secrets are specific to a Kubernetes namespace. So when I start talking about namespaces in the next episode, you'll need to remember that any namespace that pulls an image from a private registry will need a pull secret defined in that same namespace. Now, for the second time today, I'll hand things back over to me. I don't think that'll ever be not awkward, but hello again. It is me, and I was just talking to you as myself, but that was actually yesterday, so very strange, but it at least lets me take a little drink and take a break without you hearing me drinking my water and being weird on the stream. So anyways, it looks like things are working now, so that's awesome. The pod is actually deploying because we added the image pull secret. And we can talk a little bit more about some peculiarities with images and polling and things like that in different situations in the future. One thing to keep in mind too is some people have like air-gapped Kubernetes clusters, and there's some special things that you need to do if you're going to set that up. But this is Kubernetes 101, not Kubernetes 404, so we're not going to talk about that in this series. So we have the deployment running, and that's awesome, but we need to actually use it. Right now, if I go in my web browser, there's no way for me to actually get to this. So we need to expose the application to the world so that we can get to it from the outside. So somebody says, yesterday, same shirt. You notice it said 9 a.m., so technically I could be lying. In my terminal, it was saying that the times were around 9 a.m. So, but yes, it was yesterday. Using the magic of video editing, I actually changed shirts. I did not wear this shirt 3 days in a row. So anyway, we're going to expose this application using kubectl expose, and I'll get into how this works in just a second. So I'm going to expose this deployment that we created, hello go, and we're going to expose it on port 80, although we won't access it on port 80 on the cluster itself because we're going to use a node port, which I'll talk about in a second. And the target port, this is what it's going to look at in the containers running inside this deployment. The target port is 8180, and you'll remember that if I go to Kube 101 and go to episode 3 and go to the examples and go to the Docker file, that is the port that we're exposing. And in the little Go app that we ran, that is the port that it's listening on right here. So 8180 is the port that we're going to use. We're going to target request to that port, and we're going to say type equals node port. And one reason I'm using node port here, in case you do know something about Kubernetes, is that this will work on the Kubernetes cluster running in Minikube, and it will run on a cluster running in Linode, if you're doing it that way, very easily. And what this does is a node port service, and when you run kubectl expose, it's going to create a service in Kubernetes. A node port service will run in Kubernetes in its networking layer, and it will take requests from a port on every node in the cluster. So it'll randomly assign a port on every node, and it'll take all that traffic into this little service, and it will route those requests to one or more, however many pods are running behind that deployment. And you can have services that expose different things. It's not just for deployments, but for the most part, in what we do, especially deploying web applications and things like that, you'll be exposing deployments and having services for deployments. So we're going to create this, and I can get the service information with kubectl get service and hello go. And again, when you do things with the defaults, it's just going to take the name of the deployment and make a service for it, just like it took the name of the deployment and added an app label to all the pods that run for it. So we did that, and you can see that the port that it's running on is 32630. So we can get to that. Now, this is the cluster IP. This is an internal IP address using Kubernetes' own internal software-defined network that it runs on its own. So we can't access that. If I try going to that in my browser, I'm not going to get anything because it's a private IP address inside the cluster. So this node port is actually on the IP address of any node running in the cluster. And for Minikube, I can get that IP address with Minikube IP. And I mentioned this in the first episode, but might as well cover it again here. This is the IP address of the actual Minikube instance running on my computer. So I'm going to go here. I'll open up a browser window and go to the port that it's running on, the node port. And I should get, hello, you requested /. So it's working, and if I give it a different URL, it'll give me that. So with Linode, it's a little bit different. There's not there might be a command somewhere using a utility, Linode IP. But for Linode, you just get the IP address of one of the nodes in your cluster, and that's the IP address you could use. And you could use any of the nodes. You can confirm that this is working by using all the different nodes in your cluster. They'll all be exposing the service on this port. So that's the simplest way if you have like an accessible cluster on the internet or on your machine. A node port is an easy way to expose services and test that they're running in a web browser or something like that. So the next thing that we want to do, though, is a lot of applications like Hello Go. This application can probably serve a lot of traffic very quickly, just running one instance. But if we do have multiple nodes in our cluster, or if we want some redundancy when we're doing upgrades of the application, where new ones come in and it's not killing off the old one before the new one comes, something like that, we can have multiple instances of it, and that's very easy to manage with Kubernetes. You don't have to create extra servers and things. All you have to do is, in a deployment, say, give me multiple replicas of this. And by default, when you create a deployment, it will just give you one replica, which is one instance, but that's not very highly available. And if you have multiple nodes in your cluster for redundancy, if one of the nodes dies and it's the one that was running that one instance, that one replica, then your application will be down until Kubernetes identifies that and brings up another one in its place. So that's never a good thing. So we want to have multiple replicas so Kubernetes can spread them across our cluster and allow them to use more resources and serve more requests. And the cool thing about Kubernetes services, thank you very much, Jay. The cool thing about Kubernetes services is that they will continue routing those requests to all the backend pods that you have running, all these different replicas. So we can change that by editing the deployment, just like we did in the video a few minutes ago. Kubectl, edit, deployment, Hello Go. And if you go down here under spec for the deployment, it's replicas. Now, I didn't mention this too. Kubernetes has a lot of, you're going to deal with a lot of YAML. You can actually do things in different syntaxes. You could do it all in JSON if you wanted and use different tools and things, but you're going to want to know the basics of YAML. And I'm not going to cover that too much in depth other than what we need to know for this series. But YAML is fairly simple. The one thing to keep in mind is you need to mind your white space. So if I go in Vim here and I'm adding in tab characters, Vim is going to automatically detect that tabs are two spaces. And YAML is in favor of spaces, as am I, but I know that I probably just lost 2 or 3 subscribers for saying that. But anyway, Vim is going to auto-detect that, but whatever editor you're using, you need to make sure that you're not going to use mixed tabs and spaces because that can break the YAML formatting. And it's important to have the right level of indentation in YAML, otherwise things can mess up. Anyway, for this case, we're going to change replicas from 1 to 3, and when I save this file, so I just changed it, and then I'm going to say WQ to write and quit. And Kubernetes is going to check the syntax. If there's a problem when you edit one of these files, Kubernetes will output the problem at the top of the file and leave you in the file. As long as there's no problem, though, it'll dump me back to the command line and start applying the changes that I made to the cluster right away. So I'm going to do that, and then I'll say kubectl get deployment. Hello Go. And we can see that already it seems like it already did the change. So I'm also going to say kubectl get pods -l app equals hello go, and make sure. So it looks like two of them. These 2 new ones are already up and running. So it's very quick, especially if you have applications that are lightweight and small and don't have to do a lot of setup work. Sometimes applications might need to do extra setup work when you start running them in the cluster, and we'll talk about that further down in the course. But if they're lightweight applications and the container images are pretty small, then scaling up is extremely quick. And later on in the series, we're going to talk about how to make this happen automatically in response to demand. Like if you start receiving a lot of web traffic, or if the CPU starts going high, you can scale up very quickly in Kubernetes. And that's one of the best things that I like about Kubernetes is I don't have to worry about things like if I were on Amazon, I'd have to set up an automatic load balancer and set up some rules for it and do the scaling. And the scaling usually took a couple minutes per instance when they came up. So this is super fast, super efficient, and very nice. Now, the other thing that you might be wondering is how is Kubernetes going to route requests to these things? So if I go back over here, and I'm refreshing this page, it's still working, but how do I know that it's actually going to spread the requests over all these different instances? So one quick way to monitor in Kubernetes the logs for all these pods, because I think it was last episode, I showed you that our application is actually logging all the requests, which is good because then we can debug the thing if we ever need to. Kubernetes has a nice little handy kubectl logs functionality built in, and I'm going to follow the logs with -f just like I would if I were doing a tail. And then I'm going to use the same label app equals hello go. And the advantage of using labels is I can use this label and it's going to get me all these different pods because all of them have that label attached to them because they're all part of this deployment. And I'm also going to use another option called prefix equals true. And what that does is it lets Kubernetes show me which pod and which container in the pod is running. So if I do this, you can see that there's a bunch of requests from N92KC. Those were the initial ones. And those were this initial pod. And then there's some from MRZXC. Long term, as you go down this path, you'll notice that there's a lot of these kind of things. You don't really think of these containers as pets anymore because you really can't, because you can't even identify them by a human readable name. So Kubernetes helps break you free of that and think of all of your applications running in cattle mode. And really, you know, if I delete this pod, in fact, I'll go ahead and do that really quick. Kubectl delete pod that. And let's go back once it finishes deleting. Let's see. So I'll go back to here and you can see that it just brought up a new pod in its place. Kubernetes doesn't really care what happens to your pods and knows that pods come and go, containers die. That's not a big deal, and now a new one's running in its place. Anyway, I'm going to go back and go into the logging and go back over to Safari, and I'll refresh this, and you can see it seems like there's some sort of pinning based on the client or the session or something, because every request here that I'm doing is going to Z7. But if I open up another browser, so I'll go to Chrome, and I'm going to go to, I'll do hello. I'll go in Chrome and go here. And it's still doing that same one, but yeah, let's try curl. Go here. Okay, so curl hit a different one. So Kubernetes kind of divides things up. You can actually get some more control over that, and we're going to talk later about something called ingress in Kubernetes, which gives you even more control over how traffic comes into your cluster and is routed to backends. But Kubernetes services by default, if I say kubectl get service. And another note that I should say here, because you'll see me do this just because my brain works in different modes, you can also use shorthand for some of these things. So SVC equals service, you know. So instead of writing out service all the time, you can write SVC. A lot of people also alias kubectl to K. I don't do that just because when I train people on things, I don't want them to think that K is the way of things. And, you know, you can set up that shortcut if you want, but I'm not going to do it here. Kubectl get service, hello, go. And actually, I'm going to use -o YAML. -o changes the output of it. So this output is just a quick at-a-glance output for the screen. But for any object that's in Kubernetes, you can get the YAML for it directly by just saying kubectl get service, or you could edit it too, but if you edit it and accidentally make a change, that'd be bad. So I'm just going to get the entire output for how this service is defined in Kubernetes and how it's running. And down here you can see that it has this session affinity setting, and it's set to none, and that means Kubernetes is doing whatever its default is, which seems like it's kind of all over the board. You can see it, you know, a lot of requests went to this container, then it started going to this container. I don't know exactly how Kubernetes routing engine works in the back end. And as somebody who's worked a lot with like Varnish and HA proxy and Nginx and things like that, there's a lot more control for whether you're using round robin or session affinity or IP affinity or whatever kind of thing. So I don't know how this exactly works when it's set to none, but it seems like it's kind of doing something session affinity like. But anyway, you can get into that, and I'm sure somebody probably knows a lot more about the way that service routing works in Kubernetes and could school me on that, but we aren't going to go deep into that today. All right, so we have this application running, and we have the pods up. There are 3 pods right now, and if I kubectl describe the deployment, hello go. I can see that right now it's running that version 1.0.0. Now, the marketing team came to me and said, let me go over here. They said that this string of, let me go back to an earlier version of it. Yeah. Oh, this is the initial version. This is the new version of the app. So marketing came back though, and they said that the version that I had for version 1.0.0, which is here in episode 2 from last time, it used the word hello. Hello you requested. And they said, you know what? In today's day and age, the word hello is way too formal. We want to change things up. We want to be more hip and cool. And so you guys need to drop all of your work on everything else you were doing, because obviously maintenance and technical debt are not important. It's more important to be hip and trendy. So, there are some good marketers out there, but I'm just having a little fun. So anyway, they want us to change it to hi, because that's a lot more trendy. That scores well on our A/B testing, and it creates more engagement. People stick on the site longer. So yeah, we want to deploy that. And so I created this 1.1.0 version that has that in it. And we want to deploy that. We want to roll that out to the cluster. And so there's a few different ways that you can do that. And long-term, we're going to get into ways that you can automate this process with Git or with a system like Jenkins or something like that. But I'm going to show you 2 ways to do it. One way is to say kubectl edit deployment, hello go. And if you go in here, you can go down to where the template is and then change the container image here. I could just say 1.1.0. There's a shorthand way to do it though. Oh goodness, I'm screwing up my thing here. Let me get out of here quit. All right. Sometimes when I do Vim while I'm talking, I just can't, my brain stops working. Anyways, that's one way to do it. The other way is to use some shorthand that kubectl has, and I can say, let's see, kubectl set image, and that allows me to change the image for a given deployment or a pod or something like that. So I'm going to say set image deployment / hello go kube101 go equals, and where I'm getting this from is this is the definition of the container that's being used here. So you can see by default it takes the name of the container, not the namespace and container, but just the container itself, and it labels the container name like that. You can specify the name of this container. I could have called it my special app or something, but I didn't do that, so this is the default that it uses. So this is the container name, and then I'm going to set it to gearling_guy /cube101-go 1.1.0. Do that. Then I'm going to watch the pods. So watch kubectl get pods -l app equals hello go. And I'm going to see that it already brought up the 3 new pods. So since this is such a lightweight app, it's very quick to bring up the new version. Even pulling down that container, it's only like 6 megabytes. But it was very quick pulling that down, and it terminated the old pods. What Kubernetes does by default is it will bring up the new pods, make sure they're running, and then after they're running and working, it switches the service to point to those new pods, and then it terminates the old ones. And it might take a few seconds to clean them up, but it does that, and it's a rolling deployment. And you can actually control a lot about how that happens. And this episode, I'm not going to deep dive into controlling rolling deployments and things, but if you look at the deployment options here, it does have a few things here like strategy, rolling update. These are the defaults that it sets up, and it will make sure that there are no more than 25%. In this case, there's three replicas, so that would be one of the 3, I guess. It makes sure that there's no more than that percent unavailable at any given time. So while it's doing the update, it's going to bring up a few, it'll tear down a couple, make sure that all the new ones are running. Then it'll bring up a few if you had 10 or 20 replicas I'm talking about. And it'll do that so that your application is never actually down, which is awesome. And I'm going to talk a little bit about some caveats there, especially because some applications that are out there might not take it that well if you have multiple versions of it running at the same time. So we have to work with our applications and with our application developers to make sure that when they build things and when they update them, they aren't done in a way that can break when you're updating things. So let me get back out of here, and let's see. I need to get back to where I am in the notes because I've talked way ahead of where I have my marker. All right, so we can also make sure that, we saw that the pods were rolled out. I'm also going to say kubectl describe deployment hello go. and make sure that the pod version is now 1.1.0. And I can also confirm in my browser, if I go here, it has hi. Now, we deployed this, and this is not from experience in any way, of course not. That's sarcasm if you can't tell. But marketing just called up my manager and said, you know what? We just found out that the word hi actually means a very, very bad word in some random foreign language that nobody actually uses and nobody accesses our site. But you know what? This is an emergency, and I know that you guys are going to get back to fixing that other huge bug that's causing you to have to do things every night. But this is the biggest emergency ever, and we're not going to admit that it's our fault that we caused all this work for you, but you guys need to drop everything you're doing and fix that and roll it back to the previous version. So luckily, Kubernetes has an easy way for us to do this, and it's called kubectl rollout. And when you do a deployment, when you change a deployment, Kubernetes rolls that deployment out, and you can also view the history of deployments and also undo things or switch back to an older revision. So we can get the history just to show you of the deployment. Hello, Go. And it's going to show me that there are 3 revisions. Now, there's this change cause field. This might actually go away at some point. There's a way to put a message in here. It's a little complicated. If you're building automation for it, you might want to set this up, but doing it by hand is a little annoying. But there is a way that you can add a little message in here that shows like updated to version 1.1.0 or something. But all we need to know is that the first revision was when we deployed this deployment initially, and it wasn't working. The second revision was when we added the image pull secret, and then it started working. This third one was updating it from 1.0.0 to 1.1.0. So I want to undo this previous, this last revision, and the quickest way to do that is to do kubectl rollout undo deployment. Hello, Go. And that's going to just roll back the deployment that I just did. And if I go up to the pods and watch them, you'll see that it already has done it. It has the 3 new pods running, and we'll confirm with kubectl get describe deployment. We'll confirm that it has switched back at this point to 1.0.0. And if I go in the browser, marketing is again happy because it says hello, even though apparently that's not very trendy and hip. It's a safer word. Now, obviously, the word hi, as far as I can tell, the word hi does not have any negative connotations, but I am speaking from experience that these kind of things happen all the time, and you have to deal with them. So Kubernetes helps us to do these things, and it's pretty nice. Now, I mentioned earlier, and I'll mention it again, your applications have to be designed in a way that lets you do these things to be able to deploy with a rolling update and to be able to roll back. If you have an application, and I have some experience with this, applications like Drupal and Magento, I'm traditionally a PHP developer. Applications like that, what they would do a lot of times is you would apply an update to your system, and the update would all of a sudden change database schemas and would make a breaking change, like it would change the column name of something, or it would change an entire table to something else. And so the new version would work with that, but then you're like, oh my gosh, I forgot there's a bug in this schema translation, and we need to roll back. So when you roll back, it's not just rolling back your application, you have to roll back a database to a previous state. And so things get really complicated if you have applications that aren't built for this kind of rolling update. So you need to make sure that you're talking with application developers and using software that has the ability to update and roll back cleanly. And one way to do that, and one way that I've built all of my applications that use things like databases, is instead of having an update modify a schema, what you do is you like create a duplicate table, or you add a new column and start using the new column in the new version, but also translating it and keeping the old column up to date. And then at a future point, maybe 3 or 4 point releases down the line, then you drop that old column once you know all your new code is working. So it requires a little bit more discipline, but it allows you to do this update and rollback process a lot easier because you're not breaking your entire application doing a rollback. So that's something to keep in mind. It's one of the things that you start realizing, even if you're just using, even if you're deploying a big application in production in general, everybody has had to roll something back at least once in their lifetime, if you've been in this industry long enough. And I'm pretty sure that most of us have a painful story about a rollback that's gone horrendously wrong. And anything that we can do to help prevent that is a good thing. So let's see. So that is all I have for today's episode. And in the next episode, this was kind of a convoluted example. It's really simple. It's just a little thing that prints out a line. It has no state that it has to track. It has no persistence. There's no database it's interacting with. But it does show all the different things that you can do with deployments, and it's important to get a basic understanding. And a lot of people have also asked me on Twitter especially, oh, are you going to talk about this magical tool that you can use with Kubernetes, or this system that uses with Kubernetes? And I'm not going to get into some of those until very, very late in this course, mostly because just like with Git, I don't like the idea of using a tool that provides magic layers on top of something until you understand the magic layers underneath. So we're going to stay in the command line most of the time and do things manually always first so that we can understand how those manual parts work before we get into these fancy tools that automate more for you and do more for you behind the scenes. So next episode, we're going to take a look at an actual real-world application running inside Kubernetes, in this case, Drupal. And the reason I chose Drupal is there's actually two reasons. One is the company that is sponsoring this, Amazy.io. I knew them a lot from back in the day from a lot of the Drupal things they do. They do tons of different things too, but they have been highly involved in the Drupal open source community, as have I, so I know Drupal really well. But it also is an application that is legacy and modern. So it has some features that are hard to deal with in Kubernetes and some features that are easy to deal with in Kubernetes. And I want to show some of those things because I know a lot of us are probably going to be running clusters that run some apps that might be stateless and modern and fancy and amazing. But a lot of us are going to be running applications that are more practical and old and have a history to them that are not as easy to get running cloud native, like Drupal. And we're also going to find some of the new challenges that brings and how to deal with them. And we're going to get a lot deeper into YAML. So today was a very light introduction to YAML using Vim on the command line. But next episode, we're going to get a little bit deeper dive, and I'll talk about a little bit how I make sure that my YAML is correct and things like that. And thank you, Ricky Holland 87 as well. It's great to see where everybody's from. I am so happy with this course. I've been planning it for so long. Please consider subscribing if you want to keep watching these videos. And again, everything is online at cube101.jeffgurley.com. All the apps as I upload them will be available here, and this will be a reference in case you want to go back and learn more. So consider subscribing. My book, Ansible for Kubernetes, is still available for $5. And until next time, I'm Jeff Geerling.